Okay, so now let's talk about Newton's divided difference, Newton's interpolating polynomial for the same problem that we have seen previously. Okay, so if you remember in the first lecture, I showed you the formula of Newton's divided difference. Okay, so the formula was very big, and that was a general formula. It was for n order polynomial. Okay, but I can show you how you can remember it without anything. It's very easy. So we want to find out what the second order polynomial. So the first thing always is going to be fx0. Okay, then the next thing in between there will be something, and then the next thing is first divided difference. So we have to go till 2. So for the first one it is going to be x1, then again there will be something in between, and then there is going to be x0, x1, x2. Okay, and how you are going to remember what is here? So it's going to be only the first element, x minus x0, and here since this is the second divided difference, we'll take the first and the second element. We'll always leave the last element. That means x minus x0, x minus x1. Okay, okay, it's too cluttered here. Let me x minus x0, x minus x1, and yeah, this is it. Okay, so this is how you are going to remember the formula. And when you talk about the divided difference, again it's simple. If it's like this, okay, so whichever is second, you're going to write it down first, minus x0. Okay, then the same thing, x1 minus x0, and so on. Okay, but you don't have to remember this thing. You don't have to remember this. I'll show you this. I'll show you a technique where you won't have to remember all these things. You just have to remember this first formula, and that too you can derive it by yourself. Yeah. Okay. So when you talk about Newton's divided difference here, so basically by looking at the formula, I know what I need here is uh, the first divided difference and the second divided difference. And rest I think I know the value of x0 and I know the value of x1. So then I can easily get an equation in terms of x. So the first thing that I need to do is I need to find out these divided difference. Okay. And one more thing before I move forward, you can use the same logic. The way I showed you this formula, you can again use the same logic. Like if this was let us say 3 for third order polynomial, I would have written like this, plus the third divided difference x0, x1, x2, x3, and I'll just leave x3 and I'm going to write down x minus x0, x minus x1, and can you think, x minus x2, and so on. So this is how you're going to remember, but this is a second order uh, problem where you just have to use second order or quadratic interpolation. You can also do linear interpolation. Now most of you might have already used linear interpolation uh, like when you were studying different courses, when you were in different courses, you might have studied linear interpolation. Okay, this is a general formula which you can use for linear also, for quadratic also, for cubic also. When it is linear, you just have to use these two terms. Okay. Anyways, let us get back to the problem now. So what I want is I want to find out this, and I want to find out this. So to do that, we'll make a table. Let me use a bright color pen, and this I think is my favorite color. So this is xi, then this is going to be fxi, then the next is going to be the first divided difference, that is xi plus 1. We'll make this kind of table. Then this is going to be xi plus 1, xi plus 2. Okay, if you want to keep space, even more space, you can write it down like this. Oh, now let us write down the values. This is 2.5, this is 3.2, this is 2. Okay, then this is going to be 14, this is going to be 15, and this is going to be 8. Okay, so now I am showing you a visual method by which you can follow that, and you can find out the first divided difference and second divided difference. Okay, so for the first divided difference, what you're going to do here is you'll take this element and you'll take this element and you'll find out the value here. Okay, now understand this formula. This minus this divided by this minus this, that is 15 minus 14 divided by 3.2 minus 2.5. You're getting it? So when you do that, you'll see that the value that you will be getting is 1.42857. Yeah, so this is going to be 1.4. So this is on the same line. So on the same line. Again, let us move on to the next line. We'll use this and this, and that is going to be 8 minus of 15 divided by 2 minus of 3.2. So if you do that, you'll realize that the answer comes out to be 5.83334. Okay, now let us move on to the next divided difference. Again, for the next divided difference, what you're going to do is you are going to use these two values. Okay, so it's going to be this divided by this. Okay, that's going to be 5.8334 minus 1.42857. But the question is, what should be the denominator? Okay, so the denominator should be just, this is the value, just slide like this, and whatever the value is, it's going to be for this point the value is going to be 2. Okay, and for this point what you are going to do is you are going to slide like this. Okay, and you'll reach this end, and whatever the value is, that is going to be this value. Okay, so this is how visually you can find out this. Okay, so once you do this, you'll find out the value comes out to be 180954. Okay, so this is the first divided difference, and this is the second divided. This is the first divided difference, this is the second divided difference. Okay, now the question is which value you are going to use. You are going to use this value, this value, this value, or in all these, which values you are going to use. So always remember. Okay, again visually I am telling you, the first diagonal, the values along the first diagonal, you are going to use those values. So this is going to be this, and this. All the values along the first the diagonal, the first diagonal, you are going to use only those values. So this is your first divided difference, this is your second divided difference. Now what you are going to do is you are going to substitute these values in this equation. So if you do that, that comes out to be x2. Now what is fx0? It's 14. You can see here it's written already. Okay, plus What is the value of x0? 2.5. What is the first divided difference? It's 1.42857 plus this is going to be x minus 2.5 x minus 3.2. And what is the second divided difference here? Minus of 8.80954. So this equation is your Newton's interpolating polynomial. So what you have to do next is you just have to substitute the value of 2.8, and once you substitute that, you will find out the value of 2.8. What you're getting is the same equation. If you see, both look different, but the value they give is the same. So this is how you're going to solve for Newton's interpolating polynomial. Okay. Now at this point you might be thinking that given the choice, which one should you use? Should you be using Newton's divided difference, or should you be using Lagrange interpolation? Okay. Now if you see here, this is for f2. Now if I add one more point here, let us say if I add one more point 4, and let us say it's a 6.8. So you just have to add one more column here, and you can easily adapt the current situation to find out this value, the third divided difference. So that means if you want to move to third order, fourth order, fifth order, you just have to add extra elements. Okay, just have to add extra elements here, and it can easily find out the value of the point for fourth order and fifth order and so on. But when you talk about Lagrangian polynomial, what is going to happen if you want to add one more point? Again, you'll have to change everything. That means you'll have to calculate the value of L0 again. You'll have to calculate L1, because there will be another term here, there will be another term here, another term here. Are you getting it? Another term here. So that is why, given the choice, I'll always follow Newton's divided difference, because you don't have to change everything. You just have to add an extra element if you increase number of points. But when you increase number of points in Lagrangian interpolation, then everything changes. The value of every coefficient changes, and you have to do everything again. So this is why I prefer Newton's divided difference. Okay, and whichever method you follow, both are going to give you the same solution. Okay. Now I would strongly recommend you guys that please do the same problem, the problem that I did. Okay, for third order polynomial. Okay, and you'll learn a lot in this process. So please, I would suggest that you do third order polynomial and see what you're getting. And I think this is it for interpolation. Okay, and see you for the next lecture.